Welcome, ladies and gents, to PN37, where we're going to talk about the law of sines. This is section 5.5 in your textbook. And we're going to start here with kind of a basic problem. It says solve for all missing parts of a triangle ABC if angle A is 36 degrees, angle B is 48 degrees, and side A is 8. And it says recall how to sketch this triangle. And how I'm going to do it is I really don't think too hard about it. I just create a triangle, capital letters for the angles, angle A, B, C. And I know we have 36 degrees right in there. We have 48 degrees in there. And we have a length of 8 directly across from angle A, which is right here. So we have to find side B, and we have to find side C. Notice I'm using small lowercase letters. Okay, so it says, what tools have we used previously to solve for missing parts of a triangle? And then what is the problem with attempting to use those tools with this triangle? Well, we have done all sorts of stuff with right triangles. But of course, when you don't have a right triangle and you want to find angles or sides, that kind of poses a problem. So that's when we use the law of sines and cosines, as we actually talked about already last unit. Let me just kind of remind you what the law of sines looks like. Now, this is how I write it. I like putting the sine of angle A on the top and the side length A below it. Now sometimes people like putting the length on top and the sine of that angle on the bottom, and that is just fine. Whatever works for you, because these are proportions and there is definitely varying ways of writing proportion. So sine of B all over B equals sine, oops, I don't know what I was writing there, sine of C all over C. And again, big letters for angles, small lowercase letters for side lengths. Okay, so now it says solve the triangle from above. So using the law of sines, I know that I have sine of 36 degrees, which is angle A, and I'm going to put that over side A. And I know sine of, 48 degrees is associated with angle B, so 48 degrees over side B. So really essentially you just have to pick one part of the proportion. I obviously am using this right here, and from there I'm solving for B. So when I cross multiply and solve for B, I will find that the B value, and you really definitely want to make sure you're in the right mode, and you can do this with your calculator, but side B is going to end up equaling, once you cross multiply, 10.115. So that's a 0, by the way. Okay, so 10.115. From there, I can keep going. I can do the law of sines with finding side length C, but I need to find angle C first. And of course we have two angles in a right triangle, two angles in a triangle, so we can just go 180 minus the 36 degrees minus the 48 degrees, and that'll give us an angle degree of 96 degrees. And so now I can just do the other part with law of sines. So I can just use this first, this part right here again, this sine of 36 degrees over 8 equals sine of 96 degrees over side C. Cross multiply, and you'll find your value, which I'm running out of space here, is 13.536. So this is more of definitely a review, but it's one of those things where just make sure you've got it all under control as far as the mode in your calculator and that you're able to set it up. So now let's go down here and get right into an application problem, because really that's kind of where we go with pre-calculus. It says Forest Ranger Chris Johnson at a ranger station A sights a fire at the direction of 32 degrees east of north. We've talked about that. We're talking about going east from the north direction. So we know this going this way is east, going the other way would be west. Let's see, east of north. Ranger Rick Thorpe at Ranger Station B. Where am I at? I'm sorry. 10 miles due east of A sights the same fire on a line 48 degrees west of north. So here's that west going this way off of the north is west of north. Find the distance from each ranger station to the fire. So I realize the picture's drawn, but as we get into more of the physics components of this class, it's really important to really understand what this is saying. This due east, the north of east, the west of east, or excuse me, west of north, just to kind of look at the picture and really see the words as the prompts kind of get more complicated. It's really important to know those words. Okay, it says, in addition, find the distance. Okay, so it says find the distance of each ranger station to the fire. So we want to know this length right here, length B. We want to know length of side A, but it also says, in addition, find the distance of the fire from the road that connects the station. So this right here is that road that connects station A to station B, and they want to know the distance from that road directly to that fire at C. So that's definitely going to kind of change. We won't always, because we have a right triangle there, we won't always have to use the law of sines. So I'm going to erase some of this just so that we can kind of see what we're doing here. Okay, so let's get right to it. So if this is 32 degrees right, oops, this is 32 degrees right here. We got 90 minus 32, that's going to give us 58 degrees in this location. We have, with the same rationale, right in this one, we have 42 degrees. And of course we know in a triangle we have 180 degrees, so that leaves us with 80 degrees up here at angle C. So I am given this side right here, and the angle opposite of that side is 80 degrees. So I'm going to go sine of 80 degrees over 10 is equal to, and it doesn't matter which one you do first, I'm going to go sine of 58 degrees over side A. So just make sure, again, you're looking at opposite angles and sides, because those are always related. And that's really important for what we're going to talk about next. Just kind of keep that in mind. So as we continue on, we can do the same thing. Sine of 80 degrees over 10 is equal to the sine of 42 degrees over B. And this value right here, let's write it right down here. So we know the length of A, when you cross multiply and solve, should be 8.611 miles. Again, we need a unit on this one. B, we have 6.795 miles. And I know the rounding here, depending on if you're doing no rounding until the very end versus rounding intermediate through the problem, might vary a little bit. But so make sure you get a, at this level, I tend to say you shouldn't round until the very end. You should be able to use those calculators and get a nice accurate answer. Now the height, I'm going to switch colors here, is a whole nother kind of animal here. So we want to know this h, or the length right here. And this is where you really need to switch over to right triangle trig. So law of sines is great for non-right triangles, and it does work for right triangles too, but we really frown on it because it's a little slower. And then you forget your right triangle trig. So I'm going to go sine of 42 degrees is equal to the opposite side over the hypotenuse, which is 8.611. And then again, when you solve that, you end up with an h length of 5.762 miles. So again, this is not much more challenging than that top one, but it does bring in the application, kind of reminds us to talk a little bit about a couple of those things, and also brought in the right triangle trig. Okay, so now we're getting into the more interesting part of law of sines, at least in calculus or pre-calculus. It's called the ambiguous case. Let me just draw this picture first, and then I'm going to kind of get into this idea of the ambiguous case. I'm not going to again think too much about the the triangle, and I'm going to just draw A, B, C. I know my length across from angle A is 6. I know my side across from angle B is 7, and I know my angle is 37 degrees. Now, let me just take a step up here for a moment. Notice that in this example 1 that we had, you had 2 angles and 1 side. So if you want to get fancy about it, you can call that angle side back in the day. So in that situation, that's a nice, clear example of law of sines. Notice that is the same thing in the second example where we had 2 angles and a side. So again, angle, side. But ultimately you had 2 angles and 1 side length. Well, with the ambiguous case of law of sines, you actually are given enough information to solve it, but really what's happening is you're solving it down, or you're like narrowing down the solution to 2 possibilities. So think about the word ambiguous in general. Ambiguous, like if a person's being ambiguous, they're not necessarily giving you all the information to come up with a clear, defined answer to whatever. So this is that type of, we're using the word ambiguous for that exact same definition, which is that we can narrow it down, we can solve it, but we can solve it in the sense that we have 2 triangles, but we don't have one exact solution, bottom line. So ultimately, when you have the ambiguous case, you have 2 solutions. So how do I know this is ambiguous case? Well, it's not angle, side, that's for sure. And really, I hate to spell a naughty word, but it's when you have that angle, side situation. Remember back in geometry, I'm pretty sure you had a teacher probably say there's no such thing as ass in math. Well, you know what? In law of sines, when you have that, you have what's called an ambiguous situation. So what's given to us is enough information to narrow it down from an infinite number of triangles down to 2 solutions, just not a unique solution. So let's kind of go through the law of sines, and I'll kind of explain how this works. So we have sine of 37 degrees over 6 equals the sine of angle B over 7. So we obviously can solve it. That's not going to be an issue. So when I cross multiply, and then of course remember, when you solve this, you end up with sine of B. So if you cross multiply and then divide out by 6, you end up sine B equals 0.7021, and this is where you take your inverse sine to find your angle B. So you're going to do your inverse sine on this. That's how when you need to find that angle, and that's definitely a review. You end up with the angle for B as being 44.597. So again, the first thing you need to recognize is this is going to be ambiguous. They don't give you enough information to get 1 triangle. You're going to end up with 2 triangles. And we kind of know that the shortcut, or kind of like the give me, is this right here. If the information they give you is ASS, that's when you know that you have that kind of situation. Now, again, we're going to end up with 2 triangles here, and I kind of wrote big, which is going to be an issue, but I know that angle B we found was 44.597 degrees. Now, here's the thing. This is my first triangle, but I told you there's going to be 2 triangles, so this is going to be my second triangle. So all you do to find your second triangle is take your B value, your angle, and subtract it from 180. So you're going to go 180 degrees minus the 44.597 degrees, which then gives you 135.403 degrees. So let me just again make sure that you're all with me here. This is the first, that's horrible, I can do better. This is going to be the first triangle on the left side, and on the right side is going to be the second triangle to give me 2 solutions. So far I have my angles for B. Now I need to find my angles for C and the length for C. So I'm going to find angle C here. Ooh, look at, I'm trying to color code and I'm doing a horrible job. There, I'm going to undo that. So this here is going to be angle C, and of course we know angle A is 37 degrees. We know angle B is 44.597 degrees in this triangle. So when I go 180 minus those two angles, I end up with 98.403 degrees. From there, we need to finish solving this by finding the length of side C. How do we do that? Well, we do exactly what we've been doing, where we go, I'm going to write it down here, even though, I'll do it right here. Sine of 37 degrees over 6, that's from the original, original proportion, equals the sine of 98.403 degrees over C. You cross multiply that, solve, and you get a C length of 9.863 units. Okay, so this right here is one of my two solutions. So I solved that whole entire triangle given the B angle that we found initially. Now I'm going to switch over and finish solving this other side. And I've got a lot of stuff here, so I'm going to just get rid of this right here because, well, it's in your note guide and I'm sure you have lots of space. It's kind of getting me all clogged up here. So my angle B, again, for this one was 135.403 degrees. And again, we found that by just going 180 minus the other angle B. So then we go angle C, again 180 minus the 37 degrees for angle A, which is a hard fast 37 degrees, that's not fluctuating, and the 135 degrees, and you end up with an angle C of 7.597 degrees. When you do your law of sines again, and I'll do it just down here, the only difference with the setup is going to be, instead of using the 98.403, you're going to use the 7.597. So you're really solving the problem twice. Cross multiplying, and you'll get your length of 1.318. Again, the whole reason why you have two triangles, notice we solved it twice, was all because we had this pattern, which means that it's ambiguous in the sense that we can narrow it down to two triangles because the amount of information given, which is pretty good. I mean, considering that there was an infinite number of possibilities, we narrowed it down to two, but we just don't have enough information to specifically say one. And I just want to make sure you realize either one of these solutions is true with the information given. So you can work it back out and check it, and you'll find that it checks out. So again, the trick is to make sure that you recognize when it is an ambiguous case. So let's kind of come down here and just kind of work with that. So that's really the new part of this lesson, which is why I'm spending a little bit of time on it. So it says solve for the missing parts. I'm going to draw a triangle. Oops, I'm not going to draw anything here. Okay, there we go. I'm going to draw a triangle really quick. Here's angle A, B, C. Notice I don't think too much about how I draw it. So this right in here is 57 degrees. Side length 10. Notice we have a side length right across from that angle 57. And I have another length of side. So again, notice that this is following that ASS pattern. And that is, again, the key to realizing that it's an ambiguous case. So I want you to pause this video right now and actually work through this, realizing that, one, when you first set up this law of sines, so you're going to obviously go sine of 57, I can do better on that, sine of 57 degrees over 10 equals, and by the way, the one you do need to find is angle A, because obviously that's the other side you know. So sine of A over 11, when you cross multiply and solve that, that's going to give you one of your triangles. I'm going to set it up just like we did on the top. So first triangle, and this is the second triangle. And really what I tend to do is, once I find angle A, which is in this case 67.2999 degrees, if you want to go 2.3, I totally get that. So this is angle A. Then I would really highly recommend just going right down and finding angle C and side C right away. Just solve that entire triangle. Then I would at that point go 180 minus that angle A to find the other one, which again is 112.7001 degrees, and then you find angle C and side C. So find those values, and I will check that in class to see if you are understanding how to find each one of those. So again, this is an example of an ambiguous situation where you end up with two solutions, two separate triangles. Okay, so now I'm going to come down here to this last problem, and it says solve all missing parts of triangle ABC given that information. So I'm going to draw this out really quick. I don't draw my triangles any different, do I? You can shake it up if you want. There's 21, there's 8, and this right here is 61 degrees. Notice this is an ambiguous situation again. Angle, side, side. So we can start setting it up. So I'm going to go sine of 61 degrees over 8 equals sine of angle B over 21. I cross multiply, I end up with sine of B is equal to 2.296, and then you do your inverse sine on that and you'll find that nothing happens, or actually it'll err. And we've talked a lot about this, where if you end up with a sine value greater than 1, it's wrong. There's no solution. So this is saying that, you know what, this situation here that we gave this triangle can't exist. So there's no solution to this problem, which is kind of awesome. Okay, so kind of looking down here, it says, from this point forward, you should always check for two triangles when solving law of sines with only one given angle. So when you have one given angle and you can actually use the law of sines, please note that that is called an ambiguous case and you have two solutions. And while we're at it, just because you guys have tuned in for this long, let me give you these angles here. So again, make sure you can calculate these on your own. This would be 55.7 degrees, 9.850. This other triangle, using the information of this angle right here, you would find that this is 10.3 degrees and 2.132 as far as length goes. So that is it, folks. And right down here on section, I already forgot, section 5.5. Section 5.5, you're wanting to do these problems. Notice it says solve the triangles completely. You hear church bells in the background because that's my alarm. And you know what? Any questions you have, we'll take in class. Thanks for tuning in.